Hello everyone, welcome to all of you in my lecture today. So today I'm going to talk about flooding velocity in distillation column. It's a very important concept. So Git has asked the question on this particular topic two times. So that's why this is very important concept. So I'm not going to discuss all these particular parameters which is associated with this concept previously. So you can go to my YouTube channel and you can watch all these kind of video which is available on the YouTube. But I'll be talking about only flooding velocity in this lecture today. So let's say So it will be denoted as UF, and obviously the unit will be in meter per second. So if you remember the concept of parameters which is associated with the flow of any vapor and liquid on a distillation column. So if you will see the distillation column tray will look like that, and obviously some perforation will be there on this particular tray, so which the vapor will be flowing from bottom to top, and the liquid will be flowing from top to bottom. So I mean the actual diagram will look like this way. So say so this kind of I mean you'll see the tray will look like this one, right? So I have told you in my previous lecture, this one is your downcomer area, this one is normal area through which the vapor will be flowing, and the whole area is called as the cross-sectional area AC. So AD, which is called as the downcomer area, and AC is your cross-sectional area of column, distillation column, and AN is your normal area through which vapor is flowing, right? So if you remember the my last lecture, so you can calculate the normal area that is called cross-sectional area minus downcomer area, right? So this is how the relation will look like, and obviously this is just a simple mathematics and geometry. So if I'm talking about flow rate of vapor, so let's say Q dot that is your volumetric vapor, and can I write this one is m dot by rho, that is your mass flow rate of vapor divided by density of vapor. So density of vapor I'll be denoting as rho v, right? So this is just a simple mathematical equation. You have studied this in fluid mechanics also. So yeah, fine. So let's say for a stripping section, if I'm talking about generally, so for the stripping section, what will happen? V bar upon rho v. So that is called A normal multiplied with U upon, right? So what is the significance of all these things? Just try to understand. V is your V bar is your volumetric flow rate of vapor, and that will be in meter cube per second. And rho v is your density of vapor at that particular condition in the distillation column. A normal is obviously I have told you earlier that is normal area, and UP is your upward velocity of vapor. So with the help of upward velocity, we are trying to find out the flooding velocity. U flooding, that is the liquid flow rate velocity you can do. So sometimes what happens, they will give you the fraction of upward velocity is equals to flooding velocity. Let's say x fraction of upward velocity will be equals to the flooding velocity, right? So in this particular formula, what you'll see, let's say u flooding is equals to u upward is equals to, it will give u upward equals to x multiplied with u flooding. So this kind of relation will be given in the question, and from there you'll have to use this particular formula. So I can write v bar divided by rho velocity, rho v. So that is equals to AN. So AN can be written as AC minus AB, right? So downcomer area will be given to you, and it's very easy to measure, and AC will be given to you because normal area is uh, can be calculated in terms of cross-sectional area as well as in terms of downcomer area, right? So this is U upward. So I can write U upward is X into U flooding, right? So UF is your flooding velocity. So UF is called as the flooding velocity, and we want to calculate the flooding velocity of the distillation column, right? So here you can write AC and AD. I mean, AD can be given as like Y multiplied with AC. Obviously, some fraction multiplied with AD, right? So you can write V bar by rho V, that is equals to AC into 1 minus Y into X into U flooding, right? And what is AC? AC is equals to obviously pi by 4 into DC square, where DC is your column diameter. I mean diameter of distillation column. Fine. So with this particular formula, now what I can write here that V bar by rho V, that is equals to pi by 4 multiplied with dC square into what? 1 minus Y into X multiplied with U flooding. So from here I can calculate the diameter of column also. So diameter of column square, that can be written as 4 V bar divided by pi rho V, and again 1 minus Y into X into U flooding. So from here you can write the diameter of column. So that is equals to root over 4V square divided by pi rho V and 1 minus Y into X into UF. So what I'll suggest you, don't try to remember the formula. What I told you, the basics. So if you remember the basics, that mass flow rate, and if mass flow rate is given with volumetric flow rate of vapor is given in terms of in the column, then you can definitely you will be able to calculate the diameter of the column. First, second thing is that sometimes in distillation column, what you will see that flooding velocity formula will be given like that CF into, I mean, this is a correlation and semi-empirical correlation in, if you do the experiment, then you will be able to get it. So rho v, and you can write this thing CF root over rho L by rho V minus 1. So the flooding velocity formula is not, they have not given the flooding velocity formula, and if they have given you this kind of thing, CF rho L by rho V, and CF is a constant value. If it is given, then you have to use this particular formula. And again, what you will see here is, since density of a vapor is, I mean, liquid is constant, that is not going to change, very much, but if we'll talk about the density of vapor, it is drastically it's going to change with respect to temperature. If you increase the temperature, the density will get decreased, right? Or if you will decrease the temperature, the density will increase, right? It's very important thing. So here, what you will see, UF is directly proportional to rho L by rho V, right? And since we know that rho L is your constant, so finally, what I can say, UF flooding velocity is directly proportional to 1 upon rho V. Fine. So this is what the thing is. So sometimes they can ask you the proportionality based question that if I'm increasing the velocity, I mean rho V. So if density of vapor is increased 4 times, then what will the effect of the? I mean, what will be the effect on the flooding velocity? So the flooding velocity will increase by 4 times, 2 times. It will become half. It will become 1/4. So based on this particular thing, you can calculate. Now, first thing is that. Second thing, if vapor behaves ideal, like ideal gas, I'm assuming some ideal condition in order to understand the dependency of vapor density of vapor with the pressure, and if I will be changing the pressure of the column, how the flooding velocity is getting changed. So if you'll see the relation density of vapor is directly proportional to root P. So finally, you will be getting flooding velocity is directly proportional to your sorry, density is directly proportional to the pressure. So the flooding velocity is directly inversely proportional to the square root of the pressure of the distillation column. So pressure will be given, and you can get good idea about you will get idea about how you can incorporate these things over here. So sometimes they will give you the graph of CF versus L by V, L is your vapor liquid flow rate, volumetric flow rate of liquid in the distillation column, and V is your volumetric flow rate of vapor in the distillation column, and this value will be rho L by rho V. So what will happen if you will see at a very low pressure, the value of CF will be independent of pressure. So if you will see, the graph will look like this one, right? So this graph used to look like this one at a very low pressure. So if I'm talking about this particular value, this will be your, where the pressure is going to, influence or affect the value of CV. So after this particular pressure, you can see that CF is not constant. But in this particular region, CF is constant. So CF is not a function of pressure here. So CF is your function of pressure in this region. So these two regions are there. And sometimes they can give you such kind of plot and they'll ask you what will be the value of CF. And after that, from CF, you can calculate. Obviously, I've told you CF is, I mean, flooding velocity here. UF is equal to root CF root over rho L by rho V minus 1. And once you will get the flooding velocity, you can calculate the diameter of the column. So it's very important to understand this particular thing. So what happens here, just try to understand. I have told you that UF is inversely proportional to root P. So your flooding velocity is, inversely proportional to root P. First, second thing is that what I have told you, diameter of the column is inversely proportional to your flooding velocity, UF. Fine. So what you will see over here, so this diameter of column is directly proportional to what? Pressure to the power 1 by 4. So if you are going to change the pressure of the distillation column, the diameter will change by 1 by 4th of the power of the distillation column. So this is how, there will be a drastic change in the diameter of the column if you are going to change the pressure in the distillation column. So most of the time, you'll try to, fix the pressure of the distillation column in order to, you know, fix the distillation column. Otherwise, some kind of abnormalities will be there, and that will ultimately will reduce the column performance. Okay. So this is all about the flooding velocity and effect of the pressure on the flooding velocity. In the next lecture, I will be talking about some major topic and extractive distillation and some parameters or problem which is associated with distillation column like damping, flooding, entrainment, and priming and all kind of thing. Okay. So thank you all for watching my video. And if you have not subscribed my channel, please go and subscribe. And don't forget to press the bell icon button so that if I will be uploading any new video, you will be getting that the notification of the video. Okay. Thank you.